So what's top factor into? What's the bottom factor into? Okay, so what's the domain of this function then? Are there any values? Are there any values of x that we can't have, for which this function is not defined? Remember, just think the two rules, right? The only two things we have to be careful of is we can't take an even root of a negative number and we can't divide by 0. Okay, so Kirk, what are the numbers that are not part of our domain? 3 and negative 1. Okay, so x cannot equal negative, or not equal positive 3, and x cannot equal negative 1, right? So those are disallowed. If we graph this, what are the zeros of the top? Negative 3 and 1. So that's different though, right? The zeros of the top, remember the top of a fraction equals 0 when the fraction equals 0, right? We associate those two things. So we know that like 0 over 2 equals 0.
Wait, why can't we subtract the zeros?
The zeros at the bottom are places you can't divide by 0, right? So those are places that we have to exclude from our domain because you can't divide by 0, right? Remember, we looked at the example the other day when we looked at an inverse function, right? We looked at the function f of x equals 1 over x, and what did that look like? Right, it had an asymptote, a vertical asymptote at x equals 0, right? Because you can't divide by 0, and so that part of the function didn't exist, right? We had this vertical asymptote. You can approach it infinitely closely, but you can never get there, right? So the only, all real numbers were okay for that one, but x couldn't equal 0, okay? So then when we graph this, right, we've got these places at positive 3 and negative 1 where the function's not defined. And I want to be just a little bit careful with this because I run the risk here. Every example we've done so far where there are zeros of the denominator, those always worked out to be vertical asymptotes. And that's not abnormal. They usually do, but there is one instance that we just haven't had a chance to look at yet. I just want to look at one of those today if we have time, where they don't end up being vertical asymptotes. They're still not in the domain. We can't divide by 0. That's never okay to do. And so anytime we have a rational function, the zeros of the denominator are always excluded from the domain. There can do two things. One of them is they could be a vertical asymptote. And the other thing is we'll get to next. It's different though. So in this situation, because these are values of x that are zeros of the denominator and not in the numerator, they do turn out to be vertical asymptotes. Okay, so we're going to get at positive 3, we've got a vertical asymptote, and at negative 1, we've got a vertical asymptote. And we know that the zeros of the function are going to be at negative 3, so the function actually goes through 0 at negative 3, because that's a 0 of the top, and at positive 1. And our only job at this point is just to figure out how those things connect to the vertical asymptotes, right? And so that's kind of the stuff we talked about yesterday. And I get that that's, this is pretty high level stuff in a way. I mean, this is really like pre-calc / even like early calculus level stuff. But it's so much better if we can kind of get through a little bit of this way of thinking right now. It really sets you up to be able to do more later, right? And you guys can do this. I know you can. It's not like it's mathematically super hard. It's just conceptually different than what you've done in the past. So the way we talked about this then is if we want to know as we approach this vertical asymptote from the left, here's what I want to just make sure we get. If we get through this and you feel comfortable with this, that's great. That's good for today. As we approach the value of x equals negative 1 from the left, we know we're going through this point, right? That kind of helps us out a little bit. There's really only two things that could be going on. We don't know the specifics, but we're not even going to try to get specific graphs of functions here. That's not our goal. We just want to be able to sketch a function. That's what we usually do in calculus anyway. We don't need to get things perfect. We just want to get a basic idea of what the overall behavior of the function is. So what are the two things that could happen? Either we're going to go through that point and it's going to go up along the vertical asymptote. It's going to stick to it that way. Or what's the other possibility? It goes down, right? We just got to know which one it is, right? So the way we'll do that is we'll just test. We'll just see when we pick a point that's really close to the asymptote, we'll just see if we end up getting a positive or a negative result, because we know we're going to get infinite. The y value's got to be infinite because it's going to go, or it's going to approach infinity, because it has to stick to the asymptote. That's what functions do with vertical asymptotes. So how would we say that then? We're going to set up a limit of f of x as x approaches. How would I write that? Katie, how would I write that? If I want to know what the behavior is as I approach the vertical asymptote at -1 from the left.
As x approaches -1 from the negative side.
From the negative side, good, right? Does that make sense? As we approach -1 from the negative direction, what's going to happen? And we're just going to look at the behavior of each of those factors, and that'll tell us, right? So, Matthew, what's going to be the behavior of the factor x plus 3 as x approaches -1?
2.
It's going to approach 2, isn't it? Right? It's going to approach 2 infinitely closely, so we'll just treat it as a 2. In calculus, we'll call that direct evaluation of a limit, but we don't have to use those fancy words right now. The practice is the same. So this guy is going to become a 2. Let's see, Jessica, what's going to be the value of the function? What's the function, what's the factor x minus 1 approach? What value does it approach as x approaches -1? -2. Okay? So the top as a whole is going to approach -4, right? Okay? What about the bottom? So on the bottom, what about the x minus 3? Mr. Demonu, as x approaches -1, what value does that factor approach? X minus 3.
It approaches infinity.
Well, this one doesn't. This one's just going to approach a number. We've got this factor, the expression x minus 3 just is going to determine the value of that factor. Like if x were 10, it would be 7, right? See what I'm saying?
Oh.
As x approaches -1 infinitely closely, it's never going to quite get to -1, but as it approaches it, what number is that approaching? -4, right? It's going to get infinitely close to -4 though. So we'll just treat it like a -4. It's truly something like -4 a million zeros and a 1 maybe, right? But it sure does look an awful lot like a -4. Okay, here's the one that's a little bit tricky. Whoops. Right, this is the one that's a little bit tricky because what is it approaching? What number is it approaching? 0. But you got to be careful with 0 because 0 doesn't have a sign, right? 0 is exactly positioned between the set of negative and positive numbers, right? And so, big deal, you might think, right? Well, it's a big deal for a couple of reasons. First of all, because we can't divide by 0, right? And so we know that's not a number that's in our domain, right? We can't divide by 0. The function explodes there. We can only approach 0. But we know the behavior of a fraction is such that when the bottom gets infinitely small, the fraction gets infinitely big, right? So we know that the answer is going to be infinite. It's going to be explosive, right? It's going to be asymptotic and explosive. But we just have to be able to determine which one is it, because there's a huge difference. In fact, an infinitely large difference separating those two different behaviors. Either it's going up to infinity or it's going down to infinity, and they are really very different, right? So we have to know, this is the one we have to be careful with, because it's not actually 0, it's just a small number, and we need to know the sign of that, right? And that's kind of what we looked at yesterday, right? So as x approaches -1 from the left, right, from values more negative than that, Gabe, what's going to be the sign of this tiny number that we built here.
Zero negative.
It's gonna be negative, isn't it, right? Because I'm gonna get something like negative 1 point something plus 1, right? So I can get a little bit of leftover negative. And that's important, because then on the bottom, I end up with a -4 times another very, very tiny negative number, and negative times negative is what? Positive. So on the bottom, if we want to turn the bottom into a single value, it would be very small, approaching 0, but it would be positive. See what I'm saying? Okay? And so what's the overall sign then? Now we know that the magnitude of this, I've got a constant number divided by a vanishingly small number, so we know that makes the magnitude infinite. What's the sign going to be? It's got to get negative over positive, which is negative. So this is not what it does, is it? It's actually going to plunge down to infinity, to negative infinity, right? Does that make sense? And so that's the process. I got to stop. Told you I'd give you a work day. But I think that's enough actually for today. That gives you, we would just do that for each one of these, for each of these different asymptotes. We just want to do that same process as we approach from the left and the right to see what the behavior of the function is going to be. What flavor of infinity will it be? Is it going to go up forever or down forever along that vertical asymptote? Right? Does that make sense? Okay? All right. Have at it. If you've got questions, bring them up. Like